Okay, good afternoon, everyone. Welcome to this, I think this is the third edition of the Micro-school. Yeah. My name is Francesco Petruccione. I'm the director of NITheCS, and this is one of the NITheCS initiatives to share skills amongst students and others. Yeah. And we tried it for 2-3 weeks, and apparently it's a concept that works very well. Just snippets of 20 minutes dedicated to some skill that might help us or help all of us improve the productivity of what is our main job, which is research. Yeah. Today we have Omid with us. Omid Hassasfar is a PhD student in my research group at Stellenbosch University. He's working on models in quantum biology, modeling quantum effects in biological system. Originally, Omid is from Iran, where he did his master's in theoretical physics. And Omid is also an advocate for quantum computing using the Qiskit platform, and he's very engaged in Q World and Q Cousins, yeah, in particular in South Africa and in Iran, to promote quantum computing skills. And maybe at some stage we will have a micro-school introduction to quantum computing as well. Yeah. So Omid, thank you very much for offering this. I don't want to eat in your time. We have 20 minutes and the clock is ticking. Yeah. So Omid, please, over to you.
Okay, thank you very much, Francesco, for the introduction. Let me just quickly share my screen. Okay. Let me know if everything is fine. Everyone can
we can see it clearly, and it's all there. Thank you.
Okay. And okay, you can use Q&A to ask your question here as well. It's just a concept of micro-school, which means very short and very short introduction. Today's topic is NumPy, which means numerical Python. First of all, you don't need to take note or, I don't know, be worried about missing something, because the notebook is here. You can click here, and then I think after the micro-school we will share the link as well, but the recorded video. But the notebook is here, and if you click on this link, you can open this notebook, and there is an option here which is very nice. You can open in Colab. So if you click here, you can open it in your Google Colab. Technically, you don't need to install anything. Okay, just you need Gmail, and I assume everyone has a Gmail. And okay, that's it. So that's why we usually use Google Colab with for our micro-school or sometimes mini-school, because we don't need to spend time to install Python, install packages. You can use this command to check your Python version, and also there is another command, !pip list. You can use this to see the pre-installed Python packages in Google Colab. And you see there is a huge list here. And then if you go, for example, search NumPy, NumPy is also here. So I do not need to install NumPy in Google Colab. There are these are like pretty famous packages in Python, like pandas, NumPy, SciPy, SymPy, and scikit-learn. So but if you want to work in a specific package, let's say you want to do some quantum chemistry stuff, I don't know, quantum computing, you need to install. So you need one more line to install that package. That's it. Okay, so we have it. We have the NumPy package. NumPy package, actually, our data in Python is something which is called n-dimensional array. To have a flavor of what does it mean, different types of data in Python, I can quickly show you. Okay, in Python we can have a string, we can have integer, float, complex number, list, dictionary, Boolean operator type of data. These are different types of data that we can have in Python. But here we need something else. We need something which is called n-dimensional array. So And so the NumPy package is the fundamental package for scientific computing, specifically when it's come to calculation with matrix and vector, multiplication and linear algebra, machine learning. And let me just quickly show you, if you go to NumPy website, and this is the new version. And if you go down, you can see that the scientific domains that use NumPy, for example, quantum, if you want to work quantum computing, you need NumPy. Most of these packages are built on the NumPy. Like Qtip, I work with this, Qiskit, these are quantum computing. There's a statistical computing, machine learning, everything. These are very famous packages, and some of you probably are familiar with them. So all of them are built on NumPy. And then you have different, you can play around with this website and see what are important: data science, machine learning. Okay, I just want to give you a little motivation why we need this NumPy. Okay. First,
Omid, sorry, before you continue, someone, could you please share the link in the chat so that people can access it?
Okay. Okay, maybe let me just share the link of the notebook. And then if you click on the notebook, all the other links are inside the notebook. Okay, you just need to click on the other links. And even if you want to reach out to me, you can click here. Okay, thanks, Francesco. Yeah, these are the data. These are NumPy, why we need NumPy. And the first line of the code in Python, usually we need to import NumPy. Okay, this is the convention. We usually import NumPy as NP. And then I just check the, and then you can click on the run button, or you can have the shift enter as a shortcut. And then I just check the version. This is not the latest version in Google Colab. If you want a specific function which needs the latest version, you need to install it. But for our purpose, it's more than enough. Okay, before I jump to the NumPy array, which is an n-dimensional array, we need to look at the list. Okay, this is the standard definition of the list. So it's very similar to the vector, like one-dimensional vector. Okay, this is a very simple vector. But what's the difference? First of all, you can use this. I just ran it before, but if you want, you can just shift enter and then run all of them, because we don't have a lot of time. So I don't want to write them right now. I wrote it before, so you can just see the results, but it works. Okay. These are type of the L1. L stands for list here. So these are lists, and the length of the list is 5. It's completely obvious. Let's say we want to add these two lists together. Okay. The first thing that comes to mind is, okay, let's just add them. Use plus. Okay, but you see here, if you use plus L3, this is another list. Instead of adding element-wise, you technically concatenating two lists together. So here I have another list, and this list, the length of this list is 10, and you just concatenate these two lists together. So this is not the correct form of element-wise of addition. And for example, another thing, if you want to just multiply all these list elements by 2, you cannot use something like this. So this is the, of course, multiplication. But if you multiply this list by 2, so this is L3. This is our L3, and this is our L4. You can see it's kind of the length is now 20. Again, it kind of concatenate two lists together. So be careful when you are working with lists. So, and even you cannot simply add numbers to your list. Even all these, for example, this L1, all of them are numbers, but you cannot add simply +1, -1 to the list. Now we need another type of data, which is called NumPy array. Okay, and even, okay, you can do technically element-wise addition. Okay, this is element-wise addition, but you need to use for loop. Okay, you need to use, for very simple stuff, you need to use for loop. And when you are doing your coding, one important thing is do as little as possible for loop or while loop. So we call it vectorization, and I'm going to show you in the end of the micro school. Okay, and you can do it in another form. But if we have, this is how we define NumPy array. So this is, we need MP as NumPy, and we need dot, okay, we are applying NumPy here. And this is very similar to list. You see that this is nothing but the list, okay? But when you define something like that, now you have array. And if you check the type, length, shape, and the dimension, everything is more or less similar, except this part, which is NumPy array, and also shape, which is 5 by 1. And now you can see you can easily add numbers to this array. For example, now you have array, it's not list. You can add 2, for example, to this array. You can multiply, you have the element-wise multiplication here. And if you have another array, it's very simple. You can define like this. Now you can use the plus operator to perform element-wise addition to those numbers. Okay, that was the most important difference between Python lists. So this is a specific data type in the Python, and also NumPy array. Okay. Another important difference is that the data type in Python and NumPy is you can technically store everything, different types of data in the list. Here I have integer, here I have a string, here I have float, and here I have a Boolean data type. And it's fine. For list is fine. And then you can check the type of each element of your list. But for NumPy array, if you put all those different data type in just one array, it technically NumPy convert all elements to a string. So be careful when you are using NumPy array. Be careful to, if you don't put all different types of data in that array. Usually people use it for numerical stuff. Okay, I just check it. You can check this one as well. And okay, let me just review some simple operations that we have in NumPy. I define my A1 and A2, which is array number 1 and array number 2. So I can use this to do the dot product. Okay, this is the standard dot product in linear algebra. Another method that we can use is numpy.dot, and you can see that the result is 28, so it's the same. And then you can check it with pen and paper as well to make sure that everything is correct. This is the dot product. And of course, you cannot, for list, you cannot use that at. You can see that this is unsupported operand type. Okay. Again, if you want to use dot product with list, you need a for loop, and we don't like for loop for the simplest stuff. We want to reduce this as much as possible. If we go beyond 1D, 1D is the vector, 2D is the matrix. If we want to go beyond 1D, and we have a 2D, which is a matrix, and this is how we define matrix. This is, and what is matrix? Matrix is simply bunch of vectors, okay? Bunch of one-dimensional vectors, you can have a matrix. And this is 1 vector, 2 vector, 3 vector, 4 vector. So if you have 4 vector, technically you have a 1 matrix. Okay, sorry for the noise. This is another package. I don't want to explain it, but if you want to see that in a very fancy format, you can use this package to see exactly how you write in your, how you read in your books, textbooks. So you can use this one, and maybe we can do this SymPy as another package. Maybe you can have another micro-school, I don't know, in the future, but that's also is nice. Okay, if you check the matrix type, of course, again, it's an n-dimensional array. The shape is 4 times 5, which means 4 rows and 5 columns. The dimension is 2 because it's matrix, and the size is 20, means 4 times 5 is 20. You can do cool things like you can multiply by -2, for example, all these elements you have can have another matrix. and then you can check all the properties of the matrix. Okay, we spoke about dot product, and now we can have element-wise matrix multiplication. Sometimes you need element-wise matrix multiplication, and then you can check it. This is your matrix number 1, this is your matrix number 2, and then you can have the element-wise matrix multiplication like this. But sometimes we need standard matrix multiplication. So for a standard matrix multiplication, I need to first of all define another matrix, because keep in mind, this is 4 times 5, and another matrix is 4 times 5. So this is not the square matrix, so we cannot like use the multiplication simply, because mathematically is wrong. Okay, I define another matrix, which is M3. This one is 5 times 4. Now mathematically is correct. I can technically use this function, mat_mul, means matrix multiplication. That one was multiply, something like that. That was element-wise, and this is standard matrix multiplication. And then you can check this is because you have a 4 times 5 multiplied by 5 times 4, you have a 4 times 4 matrix. You can check type, shape, dimension, size. Of course, you can add 2 matrices together. But be careful, this is nice. This is, by purpose, I put it here, this error. When you want to use the matrix multiplication, be careful about the dimension. So M1 and M2 should have a consistent dimension too. Then you can multiply them. And then you can, now you know what is vector, what is matrix, and now you can do cool things like do the matrix vector multiplication. If you take a basic course in machine learning, one of the things is you have matrix, you have vector, you want to use the dot product to multiply this matrix with vector. You see that again, I use NumPy dot. And okay, there are lots of things that we can cover. How can we index or slice a matrix? But I prefer to don't go through this one. And then I want to quickly touch, can we have something beyond vector and matrix? The answer is yes, because it's n-dimensional. You can have n-dimensional, like 4, 5, 6, 1000. And how can we define this? Okay, this is a 3-dimensional, for example. So you have a, so if you consider matrix as a bunch of vectors, you can consider 3D array as a bunch of, let's say, matrix. So you have a 1 matrix, 2 matrix, 3 matrix. And I just created one of them here. So you can see this is, this 1, 0 is just a vector. This one is like matrix. And you can see here the result is something like that. And you can have a bunch of these, 1, 2, 3, 4 of them. So the dimension here is 4 matrix, or 4 times 2 times 3. Okay, you can play around with this after the micro-school. And I cannot show it with my nice NumPy package, but I use another trick to show you how you can use, how can you interpret this 3-dimensional matrix. So this is a slice 1, this is a slice 2, a slice 3, and a slice 4. So you can go beyond this, 4-dimensional, 5-dimensional, and go beyond this. And another cool things that I want to emphasize on this micro-school is, okay, you can check this and can play around after the micro-school, which is very, very important in, again, machine learning, for example, is NumPy vectorization versus Python for loop. Okay, well, let's say we have a like a random array, and the array is 40 million, okay, elements. So we have 40 million elements. So let me just press the shift enter, and then you can see that this is the shape, and you can check each element if you put it into the square bracket. For example, I want to check the this element here, okay? But keep in mind, you can start in Python, we usually start from 0, so you can check the, for example, element 0 here by this, and you can check last element usually by -1, for example. Okay, you have, and this is just a random vector, but let's just stick to this 100. And then we want to, the goal here is, this is the last things that I want to mention today. The goal is we want to square each element. So we have 40 million elements, and we want to square them with, first of all, with for loop, okay? And this is, and double star means square in Python. And this is a standard for loop. And why I use this and this, just to check the time after execution. And okay, let's run it and see how it goes. And you can see in this green arrow means that the program is calculating something. It takes a few seconds, no worries. And then, yeah, it takes like 11 seconds to check it, okay? And then you can check, okay, if the array number 100 is this, the square of this array is, you can check, okay? But another method, which is called NumPy vectorization, which is very important. Okay, you don't need for loop technically. Okay, you can just say, okay, I have another array, and I define my large array here, and I just need to square them, just this, okay, and see how it goes, okay? And you see it's even not 1 second, 0.15 second, or 155 microsecond. So that's very important. Then, in my opinion, this is the most important take-home message from this micro school, should be this one. And yeah, and there are many things here that you can check it after class, or maybe we can have another micro school with this, but we like to stick to 20 minutes. So, and yeah, I just put it some picture here. How can you slice something? How can you kind of index something? And these are pretty nice. And then you can check it. This is a matrix. And then if you, for example, use this one, you can access to this part. If you use the blue one, you can access to the blue one. And there are many things. I don't know. It depends. And the last thing, sorry, the last thing before I finish this session is, if you check this Kaggle, which is another famous website for deep learning, machine learning, there are something which is called cheat sheet, which is called cheat sheet. Click it here, and you can have a nice 1-2 page PDF that you can have access to all different things in here. For example, how to make create an array of 0, how to create an array of 1, and I don't know. These are very important. And if you want to use, if you want to work with NumPy, you definitely will use most of them. How to define array, but I just want to keep it as micro school as possible. Thank you very much. And yeah, I think I shared the notebook link, and yeah, that's it for today. Short and sweet.
Yeah, no, thank you very much, Omid. And probably, you know, it's probably better than to have an intermediate NumPy micro course in the near future, where you can go in more detail to what you were browsing through at the end, because I think that's very useful. And
maybe we can have a follow-up. Yeah.
Yeah, no, definitely. I'm sure there will be a need for that. And yeah, please, if we have maybe 1 or 2 minutes for questions, if people have something urgent, and please fill out the feedback form, because that's very important for us to see that we are on the right track. Yeah, we want to do something that is useful for everybody. And if you find it useful, please encourage your friends and colleagues to register on the NITheCS website, so that they can find out about other events in the near future. Yeah. I don't see any questions in the Q&A, Omid, sorry, there is something in the, okay, just compliments in the chat. Very interesting and useful. Thanks. Yeah, thank you very much, Mohammed. We appreciate that.
I think people need to play around with the notebook and see.
Yeah, no, and please fill out quickly the feedback form. We have only 60% feedback. Let's go to 80%. Yeah, that would be very nice. Thank you very much. And I think next week we have another mini school on LaTeX. Yeah, introduction on how to use LaTeX with overleaf. Yeah. So please join us for that as well. And we are setting up the full program for July. Yeah. So
I shared notebook because another person mentioned that please share link again. I did not see. Okay, I share it. Okay, you can just, I think you can still see my screen, I guess. If you go to this GitHub page.
And we will post it also on the NITheCS website as soon as possible.
You click here, you can find it, all the notebook you see, but you cannot run it here technically because GitHub is not for this. But you need to click here to open in the Colab, and then probably you need to connect your Gmail, which is just one click, sign in, sign up, something like that. And then you can use the run button to run all cells. Okay, it's very simple. And there is the last question is, what has been the most useful application of NumPy you have found in your work? The most useful is, as I mentioned, is the vectorization. Which I provided an example in my book, at least. But you can find a lot of examples. And even if you want to, as I mentioned in the beginning of the session, if you want to work with different packages, usually the scientific packages are built on the top of NumPy. Even SciPy, to the best of my knowledge, is built on the top of NumPy. So it's better to know the basics, and then you can go further and explore the different packages specifically for your field. I don't know what is your field, but even if you are a chemist, biologist, mathematician, machine learning, I don't know, if you are working in different field, probably you need this.
Excellent. Then, Omid, I think we are running out of time because we want to keep it short and sweet. So, Omid, thank you very much to you. Thank you very much to the participants. Thank you very much for the feedback and also for the suggestion for further micro schools. We will try to find other teachers. Yeah. And please, if you have skills, offer us to organize your own micro school. Yeah, we want to keep it peer-to-peer. Yeah, so please, if you excel at some skill, just let us know, and we can happily invite you to offer one of the future micro schools. Yeah. So thank you very much, everyone. Have a good afternoon, and Omid, we can have a coffee later. Thank you. Bye. Bye. All the best.